Well, I'm joined today by Abdoul Madjid. Abdul is a full stack developer who works for First Echo. That's a smart business integration company based in France. He writes code in R and Python that helps summarize news for their clients. And on the side, he does some amazing data visualization in R, including making some fantastic looking maps, which is what we're going to talk about today. So the reason I reached out to you was you made this visualization. It's based on data throughout the 2021 showing COVID-19 rates in all the states in the US. So let's go ahead and look at your code. That's really interesting. Well, you're only loading one package here. I know you use a couple other packages down below. And then go down here to where we're actually bringing in this data. So, oh wait, sorry. Let me restart my session. I was working on something before. All right, so I'll load that. And then let me go down where I'm bringing in the data. So COVID data. So you're bringing in this data directly from the New York Times, which has published their data on GitHub. So just if I take a look at this data, super long data,
Yes.
date, state, FIPS, which I don't know if you actually use, but then cases and deaths. Okay. And then you have USA states,
Yes.
which I'll just take a look at, which looks like all you're doing is bringing in that data and you just have the state and then the population of that state.
Yes.
Okay. So next thing you do, talk me through these lines here, lines 63 through 65, because what I understand is you're bringing in the data, you're bringing in the geospatial data. So talk about how you did that.
It is my initial ambition was when I was about to make that database was to display this map at counties level. It wasn't initially my ambition wasn't initially to put the data at state level, but with my initial ambition, I quickly faced a problem. In the United States, you have approximately 3,000 of counties. So,
yeah,
to display a maps facet with 3,000 counties for each of the 365 days, it requires a lot of computing resources. Unfortunately, my computer is not that powerful. So, I quickly turned my interest to state level data. Even with that compromise to use state level data, I faced another problem. I need to use an appropriate shapefile. Why? Because with an high resolution shapefile, graphical engine will be in high demand. So I had to choose a shapefile with low resolution. So I turned my interest to Albert USA state file because this package by Bob Rudess offer low dimension state shape file offer a low dimension shape state file. So I generally use that when I want to make maps facet with low resolution. So it's why it's.
And just so I understand, yeah, I'm sorry to interrupt you, but just so I understand, you're saying when you're making this map or the set of maps, if each map was very high resolution, it would take
Yes,
a
it
really long
will
time to make
most
them,
of the
right?
case touch Studio. So it's
Okay,
why I carefully chose my shapefile to yes.
got you. And so this code here, if I understand you correctly, is what's actually bringing in your
Yes, a low
shapefile.
resolution
And so
shapefile.
if I run that, okay, perfect. So if I run that, I can see what's returned here is some information. And then most important, because it's a shapefile, it has this
Yes.
geometry column. Okay, go ahead. And then talk about what you did next after you brought that data
Yes,
in.
the next line is for turn the projection of United States uh, United States um, form.
The
Yes, the
shapefile.
form of
Uh-huh.
the projection of the shapefile. So it's just for that that I use the ST transformer function of the SM cage.
So if I just actually add this, for
Yes,
example, and if I then, let's say I
yes,
pipe this
plus Germany
into
is
ggplot, wait, did I do that right? Oh, you know what? Sorry, it's display. Hold on, let
yes
me change
that
it so it actually, uh, okay, so that's what displays, if you don't change that. Oh, and actually first thing I notice is one nice thing about this shapefile is it brings Alaska
yes,
and
yes,
Hawaii and puts them down here, which is obviously not where they're located, but for making a map, is a little easier. So if I then add what you added here, this is going to change
yes,
the
that's it.
projection. So in other words, it's going to change
Yes,
the way that it'll show up. So, ah, interesting. So you can even see actually the longitude and latitude lines, how it's kind of curved.
yes,
Um, cool. That does look
yes,
much better. Okay. Um, and so then you save this as an object, USA states geom, which we'll see in a second. I think you use later on when you're actually making the map. All right, cool. So here, on this is where you're actually bringing in the COVID data, or not bringing it in. You're doing a bit of manipulation on it. So if we can just talk through this, and let me even run it kind of a couple lines at a time. So for example, if we run down to here, you are grouping by state and by the FIPS code, which is just a identifier, and then arranging by
yes,
date. Talk about this, because actually I wasn't sure that I quite got what was going on here. I know you wrote this code a
yes.
while ago.
There's for each what generally the New York Times publish and cumulative. I don't know if yes,
Accumulative.
cumulated number of cases. So
Hmm.
I need to for each day go to the previous day number to make the
Hmm.
subtraction to have a real number
Yep.
of cases for this unique day. So it is why I have made this manipulation to make a lag for take the value above and after make the difference
Yeah.
for have the exact number of cases for this day.
Okay. And so all of this down here is part of calculating that,
Yes,
right?
daily
You're
number
you're
of case.
taking it from the cumulative totals and breaking it so it's by
Yes.
day,
Yes.
correct? Okay. And interestingly, you're not actually, so now you're working with the COVID, you start out with the COVID data frame. So this here, and that's actually not, that's not geospatial data at all. So we're just working with a straight data frame now, or a tibble technically. Um, so I'm assuming we'll go back later on and use this USA States Geom when we actually want to plot. So it seems like your overall workflow is bring in the kind of raw data, then bring in the geometry, the shapefile, do some manipulation on the data to get it, by day. And then I'm assuming we'll go back and kind of combine that with the geospatial data to make your
Yes, is
maps.
that.
Is that overall kind of how you work? Okay, cool. Um, so this, I'm actually not going to spend a ton of time on this, but what I understand you to be doing is creating a rolling
Yes, is
average,
that.
the rolling mean,
Yes, is
right?
that. It is was when I first tried to reproduce the plot with French data, I saw something that pushed me to do to compute the number of cases with a whole mean. Is with I think this is a problem that I have with United States data store, where when I
Hmm.
take the original number of cases published, I have a problem. I have a
Yeah.
problem. It's not really a problem, but it is something that is not really coherent. Is that generally on weekend days we have a number of cases that sometimes almost null, almost equal to zero, what is not really current.
Right.
So I chose to compute a whole mean, which I think reflect the number of cases
Hmm.
for that day. So it is why I use whole mean
Yeah.
to compute uh, that rolling average for each day. So
Yeah.
after that, I chose to compute what I call incident rate. In France we call
Hmm.
it incident rate. It is something that we compute the number of cases for one 100,000 people of something like that.
Yep. Yep.
So that level made another manipulation. I
Hmm.
divide that number by the number of inhabitants for each state, because if I didn't do that, that way, I think
Yep.
the incident rate that I will have won't uh, won't reflect emergency states for each state, because 100,000
Sure.
cases in New York State doesn't have the same importance that 100,000 states in Oklahoma State. So it is why I use that
Yeah.
way to do that.
And so that's the USA states that you brought in initially, which has that
Yes,
population. So I can see here you join that in order to be able to use that population
yes,
data
yes,
to calculate, right? Cool. So you join it, then you calculate that populate or that incidence rate, cases per 100,000. And then here, it looks like you're actually putting observations into groups because if, let me actually bring up the larger version of it. But if I look at your, whoops, hold on, let me just download it and open it up. because if I look at your original plot, if I look at the legend, for example, it has these you break states into
Yes.
different groups and you use that for your legend. So it looks like here you're actually calculating that you're breaking the incident rate into
Yes.
those groups. And so if I even open up your data, I can see that each row has an incidence rate that is one of
Yes.
those categories.
That's it. What I,
Okay, perfect. And so just to reiterate, like you're doing this is just not just, but this is tidyverse stuff, like nothing particular yet that's geospatial at this point. Uh, like all you've done is just, well, with the exception maybe of roll mean, which obviously is comes from a different package. It comes from the
yes.
zoo package. And I guess there's some stuff with Lubridate, which is, well, Lubridate's a tidyverse package. You're pretty much just still working, in the tidyverse. Okay, cool. Let's go down to where you're actually making your map. So, um, you, so you looks like at first what you're doing is defining some things here that you're going to use later on. So you define, for example,
Yes.
background color, which I'm guessing is that kind of tan background that you use. You defined the font family that you defined, as we talked about before we recorded, was one that I didn't have access to. So I changed the font to be able to render it here. And then this is your caption, which shows up here. Okay, so uh, uh, oh, weird. Doesn't like that. Those little. Huh, okay, I don't know why I didn't like those symbols that I copied. All right, so this is your plot, and let me before we even get to the actual plotting of it, let me actually just take these lines and just run them because you're actually starting now. This is where the geospatial data that you saved here looks like it's coming back in. And so what I see you doing is starting with that geospatial data, and then you're joining the COVID cases RM data so that you have that, mostly that incidence rate is what you want
Yes.
to use. So you join it, and then you create this fancy date, which is using a Lubridate function, and those are, I assume, like right there. It's going to show up there. Okay, so um, walk me through the rest of the visualization here, and we can even take it kind of like line by line if that makes sense. Although to see how long it takes to run it, but like, um, let me actually comment that out so we're not saving it. So if I run it to this point, well, let me even run it, see how long it takes. Might take too long. Even that's the problem with geospatial data, right? I mean, you talked about it before, is it can be a
Yes.
bit slow to run. Um, but so my understanding here is you're running the ggplot function and then geom_sf, which is just a geom like geom bar or geom histogram or whatever, but it's specifically for shape files. Right? And so this allows you to plot this. Um, Actually, while this is running, quick question. Could you have done it the opposite way? In other words, could I have done COVID cases RM and then left join USA states by equals state equals name? What happens if I if I do that?
With that way, I think it's not that I think I know that with that case, it's generally don't work because it is we'll have a trouble to it won't keep the shape the geometry column, so it will there will be it won't show error, but it won't retrieve my geometry column, so it won't work. It's something that I have trouble with several times, so it's something that I avoid. Generally, I take my data frame with my geometry, and I left John with data frame with my data. So it is a practice that I avoid.
Yeah, I mean, I asked because I've had the same issue, and it took me a while to figure out that that's the way you have to do. I mean, there are probably ways around it, but it's just easier. And I can even see, for example, down here, if I start with the non shapefile and do a left join, now the result is a tibble. Whereas, for example, if I do this, the result is a
Yes.
simple feature collection, an SF object. And so, yeah, that makes sense. Okay. Believe it or not, this actually showed up. But of course, it's not actually very far into the code. So what it is, and specifically, we haven't done any of the small multiples that you do here where you have multiple maps. So this is just one map, and everybody is in the greater than 50 because I assume there's like one observation somewhere that's probably for each state in the greater than 50. In any case, this isn't what you want to do, but this just shows that we can start to create a map. So talk about this line and what line 126, what that
Well, it is
does.
at this line that I say that I want my facet will be with the dates. There it is with fancy date because I have make some manipulation with my date, but it was on the column date. I would I would have I would have coded a var parentheses dates. So that because I want my facet will be on each day, it's why I want facet vars parentheses fancy dates. And as I want my strip to be on the bottom, I edit parameter strip dot position to bottom. So it is what I have done at that line.
And so just to be clear, the strip is the date. So that's where that label then shows up on the bottom of each one. Okay, so this is going to take way too long. So I think what I might do, I'm just thinking if I can do a filter. So name equals. Here, I'll do Oregon because we're in Oregon. See if that.
Yes.
I'm trying to come up with a way to actually be able to run the code and have it show up in the time we're talking. Let's see how long that takes. I could also actually do. I'll do month date equals 1. So I just do January. See if that works. Wait, yeah. So this is just going to show January in Oregon. Let's see if we can get that to work. Okay, perfect. So obviously it looks kind of different because it's just showing Oregon, but you can see that it is faceting based on the date. So we have Jan 1, Jan 2, etc. Cool. I mean, to be honest, like that's the thing I really like most about this map is how you use that faceting to make the all of those small multiples maps. And it's really cool because you're doing that with this one line of code that's the same exact thing you do if you're making a faceted bar chart or anything like that. You can do the same thing. Okay, let's talk about this portion now. So I will say this was actually new to me. The color space fill, or yeah, this particular function. So talk about what's going on in between lines 129 and
What?
140.
And this is mainly color palette package in there.
Yep.
Color space package offer more than color palette. It offer the same advantages than R, a native scales function, but with additional color palette. It is main reason that I use it regularly, that package, and they have explicit function to fill uh, the value we mapped with ggplot mapping systems. So there, because I choose to make my number of COVID cases discrete by cutting it into into several sequential categories, I choose there, I can specify that my value are discrete, so it is why I use scale field discrete. And as I say that my value are sequential, I can choose the sequential sequential scales function. It's if I suppose that my value were diverging, I would have used scale field discrete diverging. So scholar space give really explicit names to um, color to the color system. So it has the same advantage that ggplot native scales function.
Cool. And so what I did is because you also have code in there that's dealing with your legend, but I actually took out all of that. I took out one other thing. And so if I just run that, I can see palette that you end up using. Let me actually compare that. So yeah, it looks similar. The one thing actually, here, let me leave in this rev equals true. I assume that's for reverse, like
Yes.
reverses the
Yes.
palette. Is that right? Um, I see. So there it goes. Yeah, it gets darker as the rate goes up. Okay, cool. So yeah, I can see how that makes a nice palette. And the rest of this then, if I understand your code correctly, deals with your legend up here. So talk about you made a bunch of tweaks to the legend. And so, for example, here, if I just run it without those tweaks, this is what the legend looks like. So talk to me about how you got from that default legend to this
Well,
legend here.
git legend function offer different
Hmm.
parameters to edit how we want our legend to look like. So there, I wanted to my legend to be at the top, so I specified that in at bottom in legend position, and I want my legend keys to be
So
yes
that's here,
less
right?
yes in
The
the
legend position.
function,
Okay.
and I want
Hmm.
legend key to be displayed on one row. So it is why I specify the parameters and row equal 1, and I can
Yep.
also specify the key and key width. Then I want my key to be a square, so I give the same value to have a square, and I want my label my key label to be at the right, so I edit the label dot position parameters, and I made some uh, modification to the term for customize my label test and my title, my legend title tests. So it is what I've done in the get legend function.
So if I just look at this, so obviously I can see here it's in one row. You said you made those squares by
Yes.
setting the key height and key width to be the same. The label position is on the right. What it, the I think the label theme, what does that do? So I know you're changing the font, but what, and I guess I'm curious, like why, what that does and why it's here versus down in the theme section.
Honestly,
Oh, are you
I think that
making?
if I have,
Oh, go ahead. Go
if
ahead.
had I would have done it in the same function, I think I don't why, but I think it will work. Never mind if I put it in term or the Git legend. So I
Oh,
think it's
okay.
something that I should try and see if will it. But I think even if I set the test in the term, I think that will work. We can try it if we want. Yes.
Let's try it. Yeah, yeah. So I left the N row as is because unless I'm misunderstanding, I think you have to have that there, but okay, so it is actually it's saying key height and key width are not defined in the element
Yes, I
hierarchy,
think
so I assume
we
that
have
means
to
they
define
can't go
that in
there.
Git legend. So let's try.
Let's see if these other. All right, so it doesn't like label position. Maybe it is the case
I
that you do
think
have
that
to
you
define.
should
Okay, it doesn't like
you
these
can't
things.
put label term and title in term. You can't
Okay,
you cannot put that there. But I think you can just edit the label test the font family. What
hmm.
I was talking about is that if you remove the family in the label.term and the title.test
Yeah, yep. Remove that.
and above. Yes,
Where
it's
else is it?
perfect. And you run the code,
Okay.
it will produce the same result. Because we have it's not because we had set the family font in the theme function.
I see. So it wasn't actually
Yes.
necessary, is what you're saying. Okay. But great. So it looks like all these things, and probably the reason they're in the guide legend here is they're specific to
Yes.
the legend itself. And obviously it doesn't show up quite correctly
Yes.
here because of the aspect ratio, but you can see here I've done that. Okay. Um, cool. So I really like how you kind of tweak the legend because I think I myself am guilty of this when I make plots, oftentimes I'll just kind of leave the default legend or just tweak them a little bit, but you showed how, with a few lines of code, you're really able to make some significant changes, which is great. So last thing I want to ask you about is, let me actually save this. Um, so now I have this COVID evolution plot saved as an
Yes.
object here. So you actually combine these two things because if I look back at your original, whoops, that's not what I want. At this, you actually combine. So you have your plot, which you made here, which would be everything highlight. that, right? And then it looks like you're adding the
Yes.
title as well as a separate
Yes.
caption. Um, and you're doing that with the CalPlot package. Talk about how
Well,
that works.
uh, generally, uh, dedicated places to caption in ggplot doesn't fit with what doesn't fit with what we want to do. This is generally the case when we have an empty spaces on in our plot where we want to put our caption. But I think
Hmm.
that that problem can be solved with additional annotation when we are working with a plot that consists of two continuous dimension. But when we are working
Hmm.
on maps or facets plots, it is a little bit hard to do that with annotation. In that case, I use
Hmm.
a co-plot ggdraw evolve function because
Hmm.
when generally you use facets and you want to edit title to edit or to set the title and the caption, it doesn't take
Hmm.
the parameters you define in your theme. Don't know if you have tried it in
Right.
the past with ggdraw function. When you make that way, it take the
Hmm.
parameter that we define in the team. So I think we can try in live and see what it will give if we set the labels and the labs, the title and the caption in 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 the previous plot.
Oh, I see. So you're saying if we put
The labs
this
in there.
there, all right, let me do this so I'm not saving it. You just run it. So what do you what's the issue that you usually see?
First of all, when you look at the plot, you see that all that white spaces that we have in our plot with ggdraw
Yeah.
function, when we set the plot background, don't have that white space.
Hmm.
You can try and see
Are you talking about like here or where specifically
aside
do you mean?
where the aside
Or
where the yes that
okay. Here, yeah, let me
or
run
try to save it
um
as a PNG or PDF or something like that.
okay. Here, let me uh, GG save COVID evolution plot um evolution plot. Oh, so so do you see the issue here?
Wait a minute. There I don't see the problem I'm talking about. Can you see the final plot with ggdraw function and we save?
Sure. Yeah, let me run that and then
Oh,
Okay, so it's probably not working because you set uh, some things particular to the probably the size. I'm guessing maybe because I'm just doing Oregon, something like that. Does that seem plausible? I don't know why it looks so different. Oh, well, first of all, I need to run that without the that.
oh, it's not working.
That's okay. That's okay. Um, let's not worry about the specifics of it. Here, I'm just gonna clear this out. It seems like the most important thing is when you do this, you are combining plot the maps, the small multiple maps. And if I even bring up your original one, you combine the small multiples maps, and then you
Yes,
add that title
yes.
and add the caption and bring it all together into a single thing. Um, cool. And just to kind of recap, it seems like, the nice thing about making maps with R is if you already use and you're familiar with ggplot, all of the things that you know how to do in ggplot apply here. So for example, the facet wrap, if you've made small multiples with any other geom, you can do it with geom SF as well. Choosing a palette you can do with color space or any other package that you use. Are there any other benefits to you? Like, have you ever made maps in any other tool and any other things that you see as benefits to making maps in R?
Oh, I think the only reason I use that, I think it's pretty simple to make that with ggplot and geom_sf. This is the main reason that uh, I use that to make my maps. I try to make with Python. It is a little bit harder than in R, so I keep making my maps with R.
Yeah, it seems like R for data visualization,
Yes.
including maps, is really a great tool.